हेलो दोस्तों, तो आज हम डिस्कस करेंगे लीड कोड बाई वीकली कॉन्टेस्ट 100 का तीसरा सवाल का नाम है फाइंड स्कोर ऑफ एन अरे आफ्टर मार्किंग ऑल द एलिमेंट्स। सो प्रॉब्लम स्टेटमेंट देखते हैं। यू आर गिवन एन अरे नम्स कंसिस्टिंग ऑफ पॉजिटिव इंटीजर्स स्टार्टिंग विथ स्कोर इक्वल टू 0. अप्लाई द फॉलोइंग एल्गोरिदम. Choose the smallest integer of the array that is not marked. If there is a tie, choose the one with the smallest index. Add the value of the chosen integer to the score. Mark the chosen element and its adjacent elements if they exist. Repeat until all the array elements are marked. Return the score you get after applying the above algorithm. Since we have to repeat the process until all the array elements are marked, and at every iteration we have to find the smallest integer of the array that is not marked. This gives us a hint to use the minimum priority queue as the data structure to solve this problem. Why? Because min priority queue keeps the smallest element at its top, so we can access the top element in order of 1. So let's see the first example. Our nums array is 2, 1, 3, 4, 5 and 2. So what we do is we make a minimum priority queue of pair of integer comma integer, where the first element of the pair is going to represent the values of the nums and the second element of the pair is going to represent the indices at which these values are present. So once we put all the elements of nums into the priority queue, the order of the elements in the priority queue will be something like this. This is 0th index, 1st, 2nd, 3rd, 4th, 5th. At top we will have the smallest element, which is 1. So 1 comma 1 will be at the top. Then we will have 2 comma 0 as the second top. Then we will have 2 comma 5 as the third top. Then we will have 3 comma 2, then 4 comma 3 and then 5 comma 4. We will also keep a boolean array marked of size same as the nums array to keep track of what all elements we have marked. 0, 1, 2, 3, 4, 5. Initially all the elements will be marked as false in this array. Now what do? We also keep a integer variable score which will initially be 0. What we do is take the top element of the priority queue, which is 1 comma 1. We check if the index 1 is marked or not. Since index 1 is marked as false, so we make it true. We add the value of the current element to our score, so we add 1 to our score, so score becomes 1. And also we mark its adjacent elements to be true. So adjacent elements of index 1 will be 0 and 2, so we mark both of them as true. Now we take the smallest element of the queue, which is 2 comma 0. Now we check if we have marked index 0 or not. Since we have marked index 0, so we will not add the value of the current element to our score and move forward. again we take the top element of the priority queue, which is 2, 5. We check if 5 is marked or not. Since index 5 is not marked, so we add the value of the current element to our score. So our score becomes 3. We mark index 5 as true, and we mark its adjacent also. So its adjacent will be 4 and 6. So we mark 4 as true. Now we take the top element of the priority queue, which is 3, 2. We check whether 2 is marked or not. Since 2 is already marked, we cannot add 3 to our score. So we move forward. Now we take the top element of the queue and we check whether index 3 is marked or not. Since index 3 is not marked, we can add the value of the current element to our score. So our score becomes 7. If we mark index 3 and also mark its adjacent elements, which are index 2 and index 4, as true and true, but they are already marked as true. So we move forward. Now we take the top element of the queue, which is 5, 4. Now we check whether index 4 is already marked or not. Since index 4 is already marked, we cannot add this 5 to our score, and so we move forward. And finally our priority queue is empty, so we return our score as the answer. So answer for this test case is 7, and indeed we are getting 7 as the result. So let's see the code for this problem. First we are finding the size of the nums array and storing it in an integer variable n. We are making a boolean array marked of size n and initially marking all the elements as false. We make a minimum priority queue of pair of integer, integer, and we put all the pairs of nums I, into the priority queue. We initialize our score with the value 0, and now while our priority queue is not empty, we keep doing this process. And what is this process? We take the top element of the priority queue, we remove it from the queue. Now we store the value of the current element in an integer variable el and the index of the element in an integer variable id. Every time we check if the current element is marked or not. Element is not marked, we add the value of the current element to the score. We mark the current element and we also mark its adjacent element, and if the element is already marked, we do not do anything and move forward. At the end, when this priority queue becomes empty, we return our score. Clearly the time complexity of this code is going to be order of n log n, because we are making a priority queue which is initially empty, and order of n times we are inserting a pair nums I. So this makes the time complexity to be n log n. Here also in this while loop, at every iteration we are taking the top element of the priority queue and removing it from the queue. This process takes order of log n time, and we are doing this process n times, so here also we are taking n log n time. Now we will try to submit the code and see if we are getting accepted or not. Clearly we are getting accepted, so thank you.